All right. Yeah, this is the fourth week of the data science program. For those that are still with us, have been consistent and have stick with us so far, congratulations. You've made it to 1 month into the program, and that's actually uploadable, right? So consistency is something that is very difficult. I know a lot of people that start something, right? Especially something as challenging as this. Data science is actually a challenging, one of the most challenging programs or skill you can get. So sticking up to this point is very, very commendable. So you should all be proud of yourself at this point, right? Yeah. So this is the seventh session. We've had 6 sessions so far. We've had 6 classes so far, right? So we've actually come a long way, and we also still have a long way to go, right? Um, yeah, so that is it for that. Let me I just want to quickly address something. Yeah, for the new students, I really want to commend you guys. Like, I just went through your assignments this afternoon, and I must say I was impressed. I was really, really impressed. And and the thing about it, the thing that made me even more impressed was that they performed very, very much better, and also the turn-in rate was higher. So a lot of them submitted their assignments, and that is actually very good to see. So just keep it up. Unfortunately, I might not be able to do the correction on the live class in this particular live class. What I'm going to do is, for those new students, I would record the correction and upload the video, yeah, on the Google Classroom. It's going to be a very short video, so it will be compressed. So don't bother about the size or anything. Right, so I'm just going to do that and upload it on your Google Classroom. So just keep an eye on the post I'll be making from now to, let's say, Monday, Tuesday, right? So also for the new student, so far you already have 2 assignments, right? Sorry, 3 assignments. The 2 assignments for the week 1 and also the assignment for week 2. So currently, the assignment for week 2 is still ongoing, and the deadline is next week, Tuesday, right? So after this class, I'm going to be dropping the week 3 assignment. So the reason why I'm just giving gaps is to enable you go through the video materials, through the recording, and give you enough time to understand and just meet up with everything. So I believe by next 2 weeks, you should have been stabilized. The new students should have been stabilized, and they should at least meet up with the class we're going to be having then. So yeah, I really appreciate and commend the efforts you guys are putting in to covering all the materials we've on all the classes we've had so far. It's actually not easy, I would say, and for most of us that have things we are doing, businesses, work, engagement, and still making out time for this. I must also commend you for that. All right, so same goes for the old students for helping with the questions, right? So I am almost always not available. So, and whenever I come to the group chat, I will see that someone has answered the question, and that's actually very good. I also want to mention the class rep and the assistant. They are actually both doing very well. Like, I'm really glad. Um, I appreciate and like the approach you are taking to ensure that the whole class is carried along, informations and answer questions and are answered appropriately, and so many other things, right? So I really love the way this class is going. I also hope we continue with this pace, and I believe God is going to see us all through, and we're definitely going to come out better at the end of the program. So just to give you a quick glimpse of the program once again, to remind you, I actually love just saying some things before the class starts, right? So at least it's not just the lecture that you'll be getting, you'll also be getting extra other information that will help you. So, as I said in the beginning of the program, that this course, this particular program, as you all know, is sponsored by Access Bank and in collaboration with some other companies, right? So, this is not just a usual, your normal program that you've seen online, right? This is actually curated and this is actually the investment in this program is high, right? So they are not just training people to get these skills. They're actually training and they're actually training you to get these skills and also be employable, right? So you have a very high chance of being employed after this program. But the criteria is that you have to have demonstrated your ability on that particular skill, let's say data science front end, whichever track you are in. So in data science right now, yeah, they're going to be picking out some persons to work, like yeah, exactly, work with some companies, right? Access Bank is going to mop up some of us here. So this is just me letting you know um the what you are going to get. So if you've been relaxing, if you've not been putting in all you can, there's still time. Yeah, there's still time to do that. So just buckle up and sit up, right? So this is something that you will definitely not regret. So yeah, enough of that. Enough of that. So let's just go straight to what we have for today. So today we are going to be continuing from where we stopped last week. Who can tell us on the group chat where we stopped exactly last week? Just where did we stop last week? So let me know if we are following and if we went back to at least go through the material that I dropped on the group chat. Yeah, NumPy. We did NumPy. Yeah, NumPy arrays exactly. So we not to waste much time. We actually introduced NumPy last week, and although we talked a little bit about objects, right? Let me just share my screen now. All right. So we talked about NumPy. We introduced NumPy to us last week. Before we did that, we talked about objects in Python. We talked about the attributes, methods, and so many other things before moving on to NumPy. And then we introduced NumPy. We talked about what NumPy is, what an array is, the particular data type that is used in NumPy. So, yeah, and I gave us an assignment to test whether we understand or we understood what was taught in the last class. So before we continue from where we stopped today, I'm just going to go over the assignments and just do correction. So those that I believe by now everybody has seen their grade. Yeah, everybody should have seen their grade by now. If you've not seen your grade, just go to my screen isn't showing. Oh, just give me a minute, please. Can you see my screen? Can you see my screen? Please, can anyone confirm if my screen is showing? Give me a minute, please. Okay. Okay. Let me just give me a minute. Let me fix that. Can you see my screen now? Please, can you confirm if you can see my screen now? Please just give me a minute. Give me a minute. Okay, perfect. So please, can you see my screen now? Can you see my screen now? All right. All right, great. All right, great. So we introduced NumPy last week, and I gave us an assignment to just um to assess your knowledge on what we did, right? So I'm just going to go over the assignment, make corrections. Those that have seen their grade, you can know exactly where you faulted. So you'd make correction, right? So now, what I love doing is that whenever I go through the assignments, I instead of me answering the questions myself, I pick a particular assignment. I will zoom in. Yeah, sure, I will zoom in. I'll pick a particular assignment that that I like, basically, that is well detailed, and use it for correction. Right. So this is one of your classmates' assignment. I do that randomly. Right. So if you see your assignment as used for correction, you just know that I was actually very impressed with it. So oh, is there still a problem with my screen? Please confirm if you can still see my screen. All right. All right, great. So let's just kick in. Right. So now in my assignment, if you pay attention to the instruction here, you would usually notice two instructions, right? So the first one is answer each question on a separate cell, either Markdown or code. By now, you should not be making that mistake again. So the people that would be tolerating such mistake from are the new students, right? And the second one is use comment in your code. So these are the two things that instructions that you have to follow. If you don't follow them, it is going to cost you mark. Right. So this comment is basically just to help you cultivate a good practice when writing code. Okay. So the first question we have here, basically we have question one, right? I included some other concepts like that we talked about that I've not tested you on yet, like for loop and functions. So I included it in the assignment. So just to assess you generally. All right. So the first question is write a Python program using for loop that iterates from 1 to 20 and print the square of each number. Now, this is a straightforward question, right? Right. So if you were in the class last week, you will know that we did for loop, right? And it asks you to iterate from 1 to 20. So you might be asking, how do I iterate from 1 to 20? We also did that last week, where when we introduced the function range, the range function. So I actually explained that because it's something you're going to be using frequently. And the last thing here is to print the square of each number. So I saw some persons that did it correctly, but they didn't print the square of each number. So we're actually performing an action on each of the elements of values in this range here that we're going to be creating. So basically what we are going to do is using the for loop for, right, num, that is a variable we're going to be creating to take in every value from this range function, from num in range 1 and 21. Now, another mistake that some of you made, right? I said iterate from 1 to 20. So some persons came here and put 1 here and then put 20 here. Now, this is actually not correct. Like you got the idea of the assignment, right? But this is not correct based on the question here. Based on the question here. So I needed you because if you included 20, yeah, that means the range or the list that will be created will stop where? Which number will it stop here? Yeah, to stop at 19. So you are not going to be getting the last number, which is 20 here. So that is not going to be correct in case you did that. So what you're supposed to do is to just make it 21, right? So 20 will be included. So you would do this for norm in range, then you indicate the range you want to iterate over, and then you come here and depending on how you want to do it. So there are several ways of writing your the body of your for loop. You can just come here and say return. Sorry. Um, print print this. You can just print it directly, right? It will give you the number. But what this person did here was that she assigned the results here to a variable, and she used string formatting. This is beautiful. Like she used string formatting to kind of make the output easy to read and understand, right? So as you can see here, for every number here, so the square of one is one, the square of two is two. So this is actually a very beautiful way to answer this question, and I love it, right? So the person is incorporating string formatting that we talked about, and just take note of this, right? So this is basically the way to answer this first question. I will not spend so much time on the other questions. I just wanted to emphasize on something. So the second question is, given a variable x is equal to 0, write a Python program using while loop that checks if x is less than or equal to 20 and increment x by 2. Now, when you are answering code questions, ensure that you read you read the question very well because there are a lot of things that are included in the question. So now in this particular question, the first one is given a variable x equal to 0. Now I've given you this variable, right? So you come here and just assign or instantialize that variable x equal to 0. Write the Python program using while loop. The tutor wants me to use while loop here, right? So you know that it's while loop you are using that checks if this x that I've initialized there, if x is less than or equal to 20. So you already know what to include now in this particular condition. Because I told you that while statement usually takes in a condition, and this condition here must be true for everything here to be executed. So it checks if x is less than or equal to 20 and increments x by 2, right? So I did this purposely, right? Normally what we were doing was incrementing x by 1, right? So, but yeah, I wanted us to increment x by 2. So it is going to be jumping 1, 1, 1. It's going to be giving us the next two values. So what you're supposed to get as output here is 0 to even numbers from 0 to 20. So you're supposed to get even numbers, right? So some persons okay, let me just not just go there. So this is basically the answer, how you are supposed to answer the question 2 using while statement. Alright, so these are some explanations. Alright, so the question 3. Now there are two questions in question 3. First one is write a function that takes a list as an argument and prints all the values in that list. Use a loop inside the function to achieve this. So write a function. Now you know how to start a function, right? Def, right? This particular function name, I don't mind. I don't care what name you give it, right? So as long as it does not it is aligning with the syntax rules of Python. So this is a name. Okay, this is fair. At least it explains what the function does, but this is actually a very long function name. So the function takes in an argument. So this is called the parameter. Yeah, you put the parameter input list. So because when you call the function, you have to put a list there. So what does it do to this particular parameter here? It comes here and say for item input list, that is for item in this particular list, print item. Chicken or simple, like that is just it. So I just needed you to demonstrate your knowledge of functions and incorporate also your knowledge of for loop in the same question. So you can create any list you want, right? So this is a function, you can always call it. So you can call it on any particular list. So any list you put here and you call this function, it's going to actually just print out the values for you. That's just what the function does. It's a very simple function. So that's for 3a. So for 3b, the question is write a function in Python that accepts a list of integers and returns a NumPy array, right, containing these integers. So now I give you a particular list that you should use, right? So basically, what you're supposed to do is convert this list to NumPy array. So this is basically how you do it. You can just name your function. So whatever name you give your function, it's fine, right? So you put your parameter, and then you return np using np dot array on this particular list that you'll be putting in here. Basically, it will give you a NumPy array, right? So before you do this, always remember to import NumPy, because if you don't import NumPy, this particular code won't run. So if you put in that list and then you convert it, this is what you're going to get. You're going to get this. Well, this is not a list. This is actually a NumPy array. If you check the data type of if you check the data type of this particular array, it should be giving you class np array, right? So that's just it for that. So question 4 now demonstrates how to create a one-dimensional, two-dimensional. So basically, I'm trying to just assess how you your knowledge on creating arrays, one-dimensional arrays to three-dimensional arrays. So I give you the sizes or the shapes of each array. So these are the confines in which you are supposed to create your array. So for the one-dimensional, you're supposed to have 5 rows. Two-dimensional, you're supposed to have 6 rows and 8 columns. For the three-dimensional, you're supposed to have 3 channels, 4 rows, and 5 columns. So basically, I don't mind the values. You can put any values inside here. It's left to you. So this is just basically how you do that. You can print your array shape, and yeah, so that's just what I want to see. For 5, there are 2 questions. Write the Python code to create 2 arrays using np.zeros and np.ones with a shape. I also give a shape here, so I should have 6 rows and 4 columns. So using np.zeros and ones. So if I come here, you'll see that if I count this, it has 1 row to 6 rows. So for columns, that's 1, 2, 3, 4. So this is 6 by 4 arrays using np.zero. So the same thing for np.ones. So 5b basically is to use the range function, arrange function in NumPy to create an array from 1 to 15, right? So it's the same thing as range, but this one is NumPy, right? So if you just straightforward, right? Just put in, and the same thing goes here. If you put 15 here, it's going to stop at 14. You're going to stop at 14. So you have to take note of that. Always, if you are stopping at the number, add 1 number to it and put that value here. All right. So question 6. Generate a NumPy array with 100 linearly spaced values. So I talked about linspace, np.linspace in our last class. np.linspace. This is basically used to create an array, right, with within a range, also indicating the number of values to create. So I'm asking here to create from 5 to 50, but between 5 and 50, I need 100 values. So you can use np.linspace to do that. So it's also straightforward. Just call the function. You should get something like this. You should get a lot of numbers. Like if you count them, you realize that there are actually 100 values here. So there's just something I need you to understand about this np.linspace. Each of these values here, they are equally spaced. So the distance between 5, the distance between a number and the next number is the same distance between that number and the next number. So if you subtract this number from this number, it will give you the same answer if you subtract this number from this number. So the spacing is uniform. Basically, it is uniform. So that's just how this particular function works. So it does not just give you a random arrangement of values. For the next question, this question depends on the question the number 4 question. So given the dimensional arrays you created in question 4, write a Python code that prints the shapes, size, dimensions, type. In this particular, some of you were creating new arrays, right? Creating new arrays in this particular question. What I needed was just referencing the created in number 4 here. So in this number 4, created an array 1D, array 2D, and array 3D. You don't need to create any array again. You just need to reference it straight up. And you need to just reference it here, right? And just call the shape, array 1D shape. And this person actually created a new array. Right? You're not actually supposed to create a new array here, but it's still the same shape. So, but what I need was you to reference the array you created before. Right, so you just have to use the attributes of arrays, shape, size, ending, data type. Right, so you should just get the information for each of those arrays here. So question 8. Now I wanted you to slice a sub array from this bigger array here. So and I indicated the number to slice. So I needed you to slice from the second to the 6th element. Now, so some of us, I didn't really understand this, right? What I mean by second is if you count normally 1, 2, this is second element. Now, this is a normal statement. I'm not trying to use Python statements here. I'm not saying from the index. I did not say second index here. I said second. So it's something you just have to note. If I said extract the subarray containing from the second index to the 6th index, you know that you start from this is the 0th index, 1 index into the second index, right? But I said second, so the second element is what? 20. So this 20 is what? The index 1. So if you're going to be slicing it, you're going to be starting from 1 and then 20, 30, 40, 50. So 0, 1, 2, 3, 4, 5. So this is this is the last element, right? Based on what I said, second to 6th element. So I said 1, 2, 3, 4, 5, 6. So 60 should be included, right? So if you count the index of 60 is what? 5. So if you put 5 here, what is it going to do? It's going to exclude 60. So that is just how Python is. Python, I don't know why, but it excludes the number that you indicate here. So you have to put in the next index to include 60. So as you can see, it has included 60 here. So that's it for that. Now, question 9, given the 2-dimensional NumPy array, demonstrate how to slice and obtain the middle row. So the middle row here is this one, 4, 5, 6. So the shape of this. Now, I need an answer in the group chat. What is the shape of this array? What is the shape of this array here? Quick one. What is the shape of the array? All right. Someone said today. I said shape. What's the shape of the array? 3 by 3, 3 by 3. All right, great. So yeah, this is a 3 by 3 array. Right, that's 3 rows and 3 columns. So I asked for the second row. This is the second row, 4, 5, 6. So how do you do that? You just come here and I told you how to slice a 2-dimensional array, right? So you just put your index 1 here. Your index 1 is the second row. This is the 0 index, first index and second index, right? So you get the second row here. So the last question here, it has 2 questions. What is the shape of the array and how many? Okay, I gave it 3-dimensional array, and I asked what is the shape of the array and how many layers or channels does the array have? Right, so that's the first question. Now, the second question, slice out the first row from the second layer using array slicing. So this can be confusing. So I actually helped by giving an hint here. So I just told you what exactly that's the values for the first row are. So you already know where you are looking at. So this is it now. This is the first row of the second channel. So this is the first channel. This is the second channel. In other places, they might call this channel a different name, right? So this is the second channel. So in the second channel, you need the first row. This is the first row. So you figure out how to slice this first row from the second channel. So yeah, um, it's just straightforward. And if you see any way that you need to make correction, please just implement that. I need also to be on the same boat as we move forward. All right, so that's the essence of this assignment. I actually take time out of the time I have to make corrections. So because the essence of assignment is to ensure that you understand the concept that are being taught. So that's it for that. I'm going to post the assignment file on the Google Class so you can just go through it. All right. All right, great. So today we're going to be continuing with NumPy. All right, so I basically um, reviewed what we did yesterday through the assignment, so I don't need to go through all this again. I've done all this with the assignments, and as you can see, that's just the essence of the assignment. So we are going to be starting from here, basic operations in NumPy. Right. So basic operations in NumPy, we are just going to be going over the operations, the kind of operations you can perform in NumPy. Remember, we've already talked about the operations you can perform in Python, right? So we talked about the operations you can perform in Python, the arithmetic operation, right? So today we're going to talk about the operations that we can perform in NumPy. All right, sorry for that. So yeah, please confirm if you can still hear me before I proceed. Can you all hear me? And is my voice loud enough? And am I audible enough? All right, all right, perfect. So yeah, all right. So today we'll be looking at the operations you can perform on arrays, right? Remember in the last class when I was introducing NumPy, I said that NumPy is for numerical computing. NumPy is used for numerical computing in Python. So almost everything you'll be doing as regards numbers, computation, calculations, what have you, you'll be using NumPy. NumPy is your go-to library, your go-to tool when performing any calculation, basically for data science and some other fields as well. So for data science, I made emphasis on this. I laid emphasis on this last class. That NumPy is your go-to tool for numerical computing and calculation. And there's actually a reason for that. It's not just because NumPy is popular. It's not just because we decided to choose NumPy as the library to use because we like it, right? So there's actually a reason why NumPy is used for numerical computation. And if you should remember, I also mentioned it in the last class, right? So NumPy is actually very computationally efficient. It actually makes the best use of your computer, making your operations very, very, very fast, right? So NumPy makes your operations, the operations you carry on the arrays, faster than you would do with your normal Python list. So if you want to perform an operation using just Python without any external library, right? So you use Python list, you can just probably initialize a Python list of numbers, right? And then you initialize another list with as another number in a list, and then add those two lists. That particular operation, if performed in NumPy, would be 3 to 10 times faster and more efficient. So I just want you to get that, so you see the essence of NumPy for numerical computation, right? So there are some key operations that we should know about in NumPy. So the first one is element-wise operations. Now, when you're performing operations in NumPy, when you are let me just create a new file here. So I will illustrate. exactly what I'm saying. All right, great. So I'll import NumPy as NP. All right, perfect. So that's very important. Like, just don't forget that. Don't forget that. Right. So now, element-wise operations. Now, we have two arrays. It's better I demonstrate it. So you array one. Let's say this is np dot array. Can come here and just put this. So a quick one. While creating an array, I didn't mention this last week. You can actually specify the data type of your array within this particular array function, right? So why creating your array, you can try to specify the data type. So if I close this array, I can come here and say the type. I hope I got that. Load 32. So now I didn't show you this in the last class, right? So but this is actually a way to specify or to tell Python which data type you want these values to be in. So as you can see, I type these values now in integers, right? But once I create this array now, these values are going to actually be in this particular data type format that we've specified here. So if I come here and let's say so what function will I use to get the data type of this array? Quick one. What function? I want to know the data type of array one. What function will I use? I'm waiting for your responses. I want this to be a very interactive class. Okay. Someone said type. Someone said dir type dtype dot array. Actually, nobody has gotten it. Nobody has gotten it. Nobody has gotten it yet. Okay. Someone said that data. All right. So let me just go over that. Now, I remember we talked about attributes, right? So I told you that an array has a shape attribute, which if you come here and say array one dot shape, it's going to tell you the shape of the array, which is 5. So we just have 5 rows. It has what? N dimension, N dim. So this tells you how many dimensions this array, or yeah, the dimension of this array. So if I run this, it tell you one, just one. So I also talked about the size that this particular method will tell you the number of values in that particular array. So if I run this, it's going to give me 5. So it's giving me 5. So and I also mentioned D type. D type. So D type is also an attribute of arrays in NumPy. So it tells you the data type of the values in your array. So this is what I expected us to say. Array one dot D type. Right. So someone said dot D type. Yeah. So this is what I expected us to say. Not type this. Okay, let me just go through. So if we run this D type, see what we're going to get. I'm going to be getting a float 32. Why? Because I indicated it here. If I change it to float 64, right? So I'm going to get, if I change it to int 64, I'm going to get int here, right? So this is actually a way to specify the data type of your arrays, right? So let me just talk about some of what you guys said in the chat, just to clarify. So some person said type. I said type function is to tell you the type, data type this will just tell you that this is a NumPy array type. Why dir? Dir, someone said dir. I'm not going to mention that. So dir is basically to show you the list of methods and attributes of an object. So let's just use it. If I say dir array 1, here's what I'm going to get. I'm going to get a list. Let me print it so it's again. I'm going to get a list of methods and attributes, right, for that particular array. So if we come to this dir here, right, if you come to this dir here, you see the type here. You can see the type. So this is an attribute of the array. So this is what the function you use to get the data type of the values in the array. So now this particular argument here can be important, but you don't have to do it, right? So it's only when you need to specify the particular data type for that array that you will use this. So someone asks, if you remove the number, is it going to give us anything? So if I come here and say array 1 dot d type, so I'm going to get the list data type for that particular category. So I'm going to get int 32. Now, if you've gone through the Python book that I sent to you to the Google Classroom, there's a portion of the book that lists out all the data types in NumPy and explains them rather. So if you had gone through that book, you would understand what all this thing is. So I'm not going to dwell much on that. So I just wanted to quickly chip this data type here, but that is not what we came here for. All right, so let me remove this. But just note that you can specify the data type of your array. But let me just leave it the type, so because it's something you might be you would come across. So let's say float 64. Right. Now created array 1, then I'll create array 2 and do the same thing here. All right, so I'll just come here and say 7, 5, 7, 4, 6, 7. Now these are two arrays, right? Whoa, what does element-wise operation mean? Element-wise operation. So now when you are performing element-wise operation in NumPy, that's actually the basic way in which NumPy performs calculations. So element-wise operation means that each of the elements are going to the operation will be performed on each of the elements of the corresponding element. So if I say array 1 plus array 2, what is going to happen here is that each of the elements now, it will just be something like this. That will bring remember your multiplication table in that we did before. So it will be something like this. 5, 7, 8, 9, and 6, 6, 4, 6, 8, 3. Right. Let me just it's going to look like this, and we'll come here. This is plus. So we're going to have 8 here, right? We're going to have 9 here. We're going to have 13 here. We're going to have 16 here. We're going to have 12 here. So I just wanted to do this so you understand exactly what is happening. So this is what element-wise operation is in NumPy. Each of the elements in the array will be added individually, right? So you are going to get this as the output. So if I do that, let me comment this out. So if I run this, come here and print. Okay, this is supposed to be 9. 9, sorry. Okay, so this is what I'm going to get. The two arrays will be added together. Each of the elements, that is what element-wise operation, each of the elements in the array would be added together to give you another array. So that is just basically, if I change the value here to, let's say, subtraction, I'm going to get this. So this is what an element-wise operation mean in NumPy, right? So you can do it on different dimensions. You can do it for a two-dimensional array, and you can do it for a three-dimensional array. So as you are moving up, we're going to talk about it. As I'm moving up the dimensions, it might become a little bit tricky to work with. So let's just do something now. If I come here and remove this, I'm going to get an error, right? So now there's something that needs to be met, a condition that needs to be met for element-wise operation to be done or to be carried out in NumPy. So the size or the shape of this array should correspond to the shape of this one, because each of the elements here are going to be performed on separately. So if we perform 3 and 6, perform on 5 and 4, perform on 7 and 6, perform on 8 and 8, and we come to this last one, we have 3, but we don't have anything to perform 3 with, NumPy is going to give you an error. This is the error it's going to give you. Operands could not broadcast together with shapes. So this is a very common error you are going to be meeting in NumPy. So you just have to ensure that the shape is aligning together, right? But as we are moving, we are going to discuss, or we're going to introduce a concept called broadcasting. So just pay very good attention. We are actually going to be saying some things. I'm going to say some things that might not be easy to grasp at the first instance, right? So you would need to just have to pay very, very good attention and probably go over it again. All right, so NumPy, performing operations on NumPy as we move up the dimensions can be a little bit tricky. It can be a little bit tricky, but if you pay good attention and if you try to understand, if you already understand the basics, it's going to be easy for you to grasp, right? So that is basically what an element-wise operation means. So NumPy allows performing arithmetic operations like addition, subtraction, multiplication, division on arrays element-wise. So this is it, element-wise. This means the corresponding elements of the arrays are operated on pair-wise, right? So that is it. I can give plenty examples. I can go on with the examples, but we are not going to exhaust that. Right, so we have something we also call universal functions, right? So we have in NumPy we have universal functions. They're also called ufuncs. So this is the short name. You'll mostly be seeing this. You can see this somewhere, maybe in NumPy website, or maybe in a tutorial that you're watching on YouTube, or a website that you're trying to you went to understand NumPy. You might see this ufunc. So this ufunc means universal function. So what do they do? So they're actually specialized functions provided by NumPy for these element-wise operations, right? So when we talked about element-wise operation, I used the symbol. So let me just go to the examples that we have here. So if you actually scroll down this material, you see the examples that I listed. So this is like an array that was created, and these are the operations that you can carry out on them: addition, subtraction, multiplication, division, right? So now we are just using the symbols that we introduced when we're talking about arithmetic operators. So this is normal Python symbol, but NumPy actually provides functions that you can use to perform the same thing, right? So it mostly are advisable that you use these universal functions than you use this symbol. So as you can see here, we have universal functions for addition, we have for subtraction, we have for multiplication, and we have for division. So if I come here and I want to do exactly this same thing, I can want to add this array one and array 2. So I can either come here and add both of them, Right. What's happening? Okay, let me run this. All right, I can come here and add the both of them. Right, it will give me this. But I can also come here and add use the universal function using u funcs. That is universal functions. Right. So I can come here and say np dot add, and then this is a method in NumPy, right? So np dot add. Now, what does this particular function take? It takes in the two arrays we want to multiply. So the first array is array 1, second array is array 2. So if I run this, I'm going to get the same output. So let me just print this out. So I am assigning the variable, so I can just print using operators. So this is the so come here and say print two funcs. All right, so this is just to show you exactly what's happening. So if I run this, I'm going to get now using normal Python operators. This is what I'm getting, right? Now using the ufuncs, I'm still getting the same thing. So basically, these are just two ways of doing the same thing. But most what I would advise you to use is these universal functions. They're actually more flexible to use and easier. So just learn that. So you can also come here and say, instead of addition, you can say multiply, right? It's going to give you this. It's going to multiply each element-wise operation. Remember, element-wise operation. It is performing the multiplication per element in the arrays you are multiplying. Right, so if I change it to let's say divide, right? So you see it's giving you the value. So you understand the idea behind this now. So now I would get there, sure, but let's just sum is another function. So this is basically what universal functions are in NumPy, right? Yeah, so that is it. We've talked about element-wise operations. So under it, we talked about the operation that can be performed on NumPy array. We also talked about universal functions too. Now, the second concept in array operations, in basic array operations, is what we call broadcasting. So this is very important, broadcasting. So broadcasting is a powerful mechanism, is a powerful technique in NumPy that allows arrays with different shapes to be combined, right? Remember I told you something that I illustrated something before, that if you have something like this and you have two arrays that are not the same shape, and you try performing this on them, you might get an error like this. Operands could not be broadcast together. Can you see it? It cannot be broadcast together with the shapes 4 and 5. So this broadcasting basically allows arrays with different shapes to be combined in a arithmetical operation. So it's something that happens automatically in NumPy. You don't need to write any code for it. You don't need to specify anything at all. Right? So it automatically aligns arrays with compatible shapes and size. See, let me just say something that is very important to know. In NumPy, most of the errors you will get, if it's possible to write this down, most of the errors you get in NumPy would be as a result of shape and dimension incompatibilities. So you will not be getting a lot of errors outside this one that I just mentioned. So the errors you'll be getting mostly would be with regards to the shapes and the dimensions of your array. So you need to understand shapes, you need to understand dimensions of array very well. I understand we've done it already here in last week, but please still go back to it. It is something that's easy to forget. It is a volatile concept. So just ensure that you constantly revise and you constantly practice and understand until you come to internalize it, so you understand shape. So once you see an array, you should already know what shape that array is, right? You see two arrays, you already know, oh, this array is one-dimensional array and it is a 4x7 array. It has 4 rows and 7 columns. So this array is a two-dimensional array, or this array is a three-dimensional array, and you already know the array size in your head. Now, when we are going to be talking about pandas, hopefully tomorrow, you will know that pandas came or was built. Pandas is actually built on NumPy. Pandas is a library that is used for data analysis in Python. So pandas is built on top of NumPy. So for you to understand pandas, you need to understand arrays. And arrays, you need to understand the shapes and the dimension. So I just wanted to say that because it's very important. So now array broadcasting, as I'm saying. So let's go to the example that we have now. So assuming we have an array, like let's say a two-dimensional array. Let me just come here and give an example. Let me change this. All right. Assuming you have a two-dimensional array 2D. All right. Let's say np.array. Then you have 3, 4, 5, 6. Then you have your comma and you come here and say 3, 2, 8, 3, 7. Then, okay, let's just stop here. All right. So let's just stop here. So let me just make it easier. Okay, so you have this to the array now, and you have a value, an int value or a number 7, and you want to multiply this 7 with this entire array. So based on what I said before, this is just one value. This is actually an integer value at this point. It's not an array, right? This is an integer value. So we want to multiply let me come here. So I want to multiply this 7 with this entire array. Now in NumPy, once you perform the operation, if I come here and say array to, okay, let me use the universal function multiply, and say array 2D and value int. What will happen is that this 7 would be broadcasted. So what is happening, you are not seeing it, right? But this is what is happening. So once you do this, once you run this particular code, this is what's going to happen. You're going to get 7 will be transformed to the two-dimensional array. So you have 7, 7, 7, 7. And then you have 7, 7, 7, 7. So this is basically what broadcasting is. This is it. So Python will broadcast this 7 to become the same shape with this array. So you can now do element-wise operation on 3 and 7 is what? 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. So you can see this is because NumPy needs this particular dimension or this particular shape to be able to perform the element wise. So this is basically what broadcasting is. Broadcasting is like replicating the value across the dimension or across the length and the columns and the rows to match the array you want to multiply it with, right? So that is basically broadcasting is in NumPy, right? So we can use let me just, because of the time, let me just give another example. So let's assume we have something like this. We want to multiply. Well, you are not seeing my expressions. What do you mean by expressions? Ezekiel, is my screen? Can you all see my screen and can you all hear me? Please check your network. I believe it's your network, right? So now let's assume we have a one-dimensional array 2, 3, 4, 5, right? So we want to multiply this one-dimensional array with 2. So now remember that normally it needs to be the same shape to be multiplied, right? But now this is a one-dimensional array, and this here, right, is a two-dimensional array. So what is going to happen when you multiply these two? That Python will now broadcast this one dimension to match the shape of this one. So you have just one row, right? But when you broadcast it, it will now be converted to something like this. So you have 4 rows here. This is one dimension to 4 rows. But when NumPy broadcasts it, you're going to now it's now going to be replicated to be a two-dimensional array. So this is what you're going to have: 2, 3, 4, 6. So this first row here would be broadcasted down. It will be created again here to match the second row that is here. So it will now be used to multiply the second row that we have in this particular 2D array. So this is basically what broadcasting is. It's not something you see, but it happens, right? So that's why I said shapes and dimensions are something you need to understand in Python, in NumPy specifically, because some of the errors you are going to be getting will be due to this shape mismatch, right? So this is just something you need to know about broadcasting. I really wish we had enough time so we can take more examples. But just understand that broadcasting basically extends the value in a particular array to match the target array, the array you want to multiply or you want to perform an operation on. So it's going to extend it to fit the shape of that array so it can perform the element-wise operation on it. So but in situations like this, now there's something you need to understand. In situations that sometimes this broadcasting doesn't work, right? So let's say we have an array, a 1D array that has just 3 rows here, and we try to multiply 2 of them. It's going to give us an error. Now it didn't extend it, so it does not. It does. This broadcasting doesn't mean we can just create any kind of array or any this thing and just expect NumPy to do everything for you. No, there are criteria that need to be met. At least one of the dimensions should basically the let me come here. I say array print array 2D dot shape. So there's something I just quickly want to say, a shortcut to help you understand how to use this array broadcasting. Now, if you get the first shape, the shape of the first array, right? So the shape of the first array is 2 and 4, right? Now, and you get the shape of the second array. Let me come here and copy this. Let's say 1D. Shape of the second array is 2. It won't work, right? It won't work. I wish I can just write on something to just illustrate, but so let me just try to explain. Now, oh wait, give me a minute. Give me a minute. Let me quickly set up something. Right, can you all see my screen?
Yes, I can see
All
your
right,
screen.
great. So now we have the first array size 2, and we have 2 and what 4. That means we have 2 rows. We have 2 rows and 4 columns. Now the second array we wanted to multiply it, which is just 2 rows, right? So this is what we had there. Now this particular combination, it won't work. This particular combination, it won't work. Why? Because in broadcasting, the colon of the first array should be the same with the row of the second array. That is a rule. It is actually a rule in matrix multiplication, right? So if you want to perform an operation on two of them, the row of the first array it should be, sorry, the colon of the first array should be equal to the row of the second array. So now if you want this to work, that means the second array has to have a row size of 4. Sorry, yeah, a row size of 4 here. So it is no longer going to be no longer going to be 2, right? So it is going to be give me a minute first. It's going to be 4, right? So we're going to have 4. So if we come back to our code, and we change this particular array to have a size of 4. We now have, and we check the array here. You see that the array shape is 2 and 4. This one now is now 4. So we can actually now perform this operation on it. It is going to work. That is it. So the rule here is that the row or the colon of the first array, the number of the first colon in the first array should be equal to the number of rows in the second array, right? So the two numbers must match. So it's just something you have to picture whenever you're trying to multiply or perform operations on arrays, or mostly 2-dimensional and 3-dimensional arrays. So because of time, we just have to move on from this. I just wanted to talk about that so you don't get confused. Hope that is clear. Hope that is clear for broadcasting. All right. Now we've talked about element-wise operation, array broadcasting, and also vectorization. So we're going to talk about vectorization. It is basically just a concept, right? It's not something you can write in code. So this is what makes NumPy fast: vectorization. So vectorization is actually it's not something that you need to know. You don't need to know how it works, because you're not building a library, right? But just understand that in case they ask you, or you are asked in an interview, right, what makes NumPy fast, right? You can say, oh, it's because of vectorization, right? So vectorization here refers to the process of applying operations to the entire arrays instead of looping over individual elements. So normally if you want to actually use Python to perform addition on two lists, you have to use loop. You actually have to use for loop, right? So vectorization is actually a very, very efficient way of doing it. So it applies the operation instantly to all the values in that array. You don't have to loop over anything. So that's what makes it faster. Looping takes time. Doing loop actually takes a lot of time. So that's just what you need to know for that vectorization. You can read up on that. I would also um, drop a video for you to watch and understand what vectorization is, as well as the book on data science handbook that I dropped on the classroom. The explanation is there, so you can read up vectorization to have a better understanding, right? So these are the basic things you would do in NumPy: element-wise operations, right? U-functions, universal functions, and array broadcasting. I told you about the rule in array broadcasting, right? Right, and also vectorization. Now we are going to move on. The reason why I'm not giving as plenty examples as possible is because of time. So just get the idea and practice with more examples on your own. So because we have other things to talk about today. So now we are going to be moving on to array manipulation. Now we've talked about array operations. Do you know this mathematical operation? Now I want to talk about array manipulation. How do we manipulate our array? So manipulation is basically like changing the array to fit the desired format you want for your work, right? So array manipulation is a crucial aspect of working with NumPy arrays. It basically allows you to reshape, transpose, flatten, join, split. So you can basically do almost anything that NumPy, within the confines of NumPy on your array. So when you are processing your data, right, when we start doing data analysis, so we're going to, I hope you know we are going to do a project at the end of this course. So all these things we are going to be learning is not just for learning's sake. There are some courses out there that you just keep learning, and they leave you to go, to give you certificate. But we're going to do a project, comprehensive project that you would, all these things we are learning, you would use them. So you would actually use all this knowledge you are gathering here for that project. Right. I'm looking for a way to actually do a kind of mini project, let's say just basically for data analysis using pandas and NumPy. Let's say by the second month, let's say towards the end of second month, right? So at least you would have an hands-on experience on how to work with these libraries, right? But for now, just understand this concept. So now, depending on your data processing need when you are doing your project, you might need your array to be in a different format. So there are different ways you can manipulate your array. So here you can actually reshape arrays. You can reshape it. Array has shapes, an array has shape. So you can reshape it to the particular shape you want. You can actually flatten your array. Flattening is actually, let's say you have a two-dimensional array or a three-dimensional array. If you flatten it, everything will be in one dimension. It will just be like a list, a long list. That is what flattening is, right? So this Ravel is the same thing, right? You get, it's the same thing. So transposing, yeah, we'll talk about that. Joining and splitting. So let's just pick them one by one and talk about them. Now, reshaping array. So let's still use the reshaping arrays. So using np dot reshape. Right. So let's just bring up the array we have before. We have a 2D array. We have the 2D array that we created. So we have this particular array size, which if we get the shape, it is going to issue a 2x4 array. So this is the shape of the array, right? So now let's assume I want to reshape the array to be 4x2. It's possible. After creating it, I can still reshape it. So how do I do that? if you come here, oh sorry. All right, so now let me quickly. So how do we use this reshape function? So basically, you just have to call the array that we've created, array 2d dot reshape. So this reshape is a method, right? Remember what methods are. Reshape, then you are going to put the new shape you want your array to be. So I want my array to be what? 4 by 2. I'm not putting bracket. Remember that you are putting an extra bracket inside the bigger bracket because this is a single, these two numbers, they are a single number and are not different things. So if you not confine them in a bracket, you are going to get, this is the error you are going to, okay, no, yeah, it's actually, not for this particular reshape. Yeah, it works. So, hey, let me check, let me just quickly check something to confirm. Okay. But just make sure you put your brackets, your numbers, the rows and columns inside the bracket. Right. So this is actually the best practice. So now when I run this reshape array, this is what I'm going to get. My array was initially, let me come here and print the array here. Initially 2D. This is my array size initially, right? It was 2 by 4. Now I reshaped it to 4 by 2. So now it has 4 rows and 2 columns. So basically, Python just changed the shape based on my arguments here. Now, there's a criteria that must be met because you can't just put in any value here. I can't just say, oh, I want to change my array to 5 by 10. It won't work, right? Because you already have number of values, a fixed number of elements in that array. So you can only work with this number of elements. So whatever it is you're reshaping it to must have the same size as this array. So this array has 12, 4 by 2 is what, 8 values. So if I'm reshaping it here, if I'm reshaping it to, let's say, 4 by 2, if I multiply this 4 by 2, it's still going to give me 8, right? So it will still retain the 8 values I have here. But if I say something like this, 5 by 2, this new array is going to give me an array size of 10, which doesn't make sense because I only have 8 values here. So when is it going to get the remaining 2 values? So if I run this, I'm going to get an error, right? See what it said, cannot shape array size of 8 into shape 5-2. Right, so you have to know that you can't just shape it into any shape you want to. So you have to maintain the size of the initial array. So I can shape it to 8 and 1, right? 8 and 1 will still give me a size of 8. So the way to get this is just to multiply the rows and the columns. So 8 times 1 is 8. So if I run this, I'm going to get 8 rows and 1 column. So this is how I'm going to get the new, this is going to be the new shape. Right? I can do basically within the confines of the size of the initial array. Let me change the this array to, let's see, make it longer. Let me make it right. So I have a 3 by 3. Okay, let me make it 4 rather. Okay, 3 by 4. That is 12, right? So I have a 3 by 4 array here. So if I come here, I print. Okay, if I come here, I print the array. I have 3 by 4 array, right? So what's the size of this array now? Can anybody just quickly tell me the size of this 3 by 4 array? What's the size? Like based on what I said. Exactly. So this is a 12 size 12 array because it has 12 values, right, in the array. So if I want to, okay, someone asked initially, what's the shortcut of commenting on my code? So it's control control slash, right? So if you just come do control slash, it will comment your code like automatically. So I can just come here and control slash to comment and uncomment. So there's a quick way to actually comment your codes in Python. Right, so that's just by the side. So now if I want to reshape this array, I can reshape it within the confines of the size of the initial array. So I can reshape it to, okay, let me know even just, I need I need to hear from you. So what are the possible ways of reshaping this particular array here? So what are the possible ways of reshaping this particular array? So what combination of values can I put here? Okay, someone said 2 by 6, 6 by 2, 6 by 6. 6 by 6. Okay, we'll try it. Okay, so 12 by 1, 3 by, exactly. So that's just it, right? It has to equate to 12 if you multiply the rows and columns. So if I come here and say 6 by 2, right? 6 by 2 is going to give me a 6 column array with 6 row array with 2 columns, right? So the size is still maintained, it's still 12, right? It's still 12. So if I say 3 by 4, it will give me the same thing. Yeah, this is actually the same thing. Okay, let's change it. 4 by 3. You see, you can change it to anything I want. I can even say 12 by 1, so 12 by 1 to give me 12 rows and 1 column. I can say 1 by 12 to give me 12 columns and 1 row, right? So I can just play around with it. I can say 2 by 6, right? I can say 2 by 6, right? It give me this particular shape. Yeah, someone asked a question now. 322, will this work? Yes, it would work. Like you can actually change your array from one dimension to another dimension. So if I put 3, I hope this is up to 12, sure. 3 times 2, that is 6, 6 times 2, 12, yeah, exactly. So this 322 will reshape it to a 3-dimensional array. So I'm going to have, as you can see, this array here. This array has been transformed to a 3-dimensional array, as you can see here. So it has 3 channels, first channel, second channel, and third. So this 3 here is the first channel, and this remaining 2 is the rows and columns. So you can actually shape it to anything you want, basically. Just make sure that if you multiply these 3 values, it is equal to the size of this first array, the initial array you are trying to transform. Yeah, so that's just basically it for reshaping. So I don't want to do much on that because of time. So yeah, so basically resizing is the same thing, like it's the same thing, but just different way of doing it. So but mostly you are going to be using reshape for it. So now we're going to be flattening array, right? There's another function called flatten that you can use to flatten your array. But what by that? Right, so if we come here, we still use our, okay, let's assign this array to array 3D. Right, so great. So I want to flatten our array. So as I said before, flattening array is basically transforming our array to a one-dimensional array to a list, not a Python list, a one-dimensional NumPy array. So I can do that by using the np.flatten function, right? So how do I do? I can bring my array here, array 3D. If I print it out, this is what I'm going to get. A three-dimensional array, as we've all seen. So if I want to flatten it, I'll just come and say array 3D.flatten. Right, so this is all you need to write. You don't need to put anything inside the flatten, right? You don't need to do anything. So if I just run it, this is what I'm going to get. Can you see it? It has flattened it to one long list of array. So a one-dimensional array. So you convert any dimension to one dimension. So if I do it for the array 2D, remember we have our array 2D, print array 2D. So you can come and say print to just separate them. So right. So now this is the three-dimensional array and this is the two-dimensional array. So I've flattened three-dimensional array to this long list. So I would also flatten the two-dimensional array to give us the same thing, right? Array 2D dot flatten print. Right. So as you can see, this is the first one. That is the third three-dimensional. This is, let me just use. I hope you are not confused with what I'm doing here. All right. I just want to make sure that this is printed out well. So this is the three-dimensional array that has been flattened, and this is the two-dimensional array that has been flattened. So you get the idea of what happens when you flatten your array. So that is just it. Flattening your array means converting it to a one-dimensional array. So we see another alternate way of doing it. So np.travel, it does the same thing. So this one is just this difference in syntax and the name. It does the same thing, right? So you can note that. Now, transposing our array. How do we transpose array? What does transpose mean? Transpose basically is flipping the array, flipping the columns to the rows and flipping the rows to the columns. Right? So that is what transpose is. So let's illustrate that. Transposing our array. So we can come here and say array 2D. So remember, this is our two-dimensional array, right? We have 3 rows and 4 columns. So if I use the transpose function, np.transpose, what I'm going to get is np.transpose. It is going to transpose it, and I'm going to get this. Now, the columns have been flipped and the rows have been flipped. The columns now are the rows here and the rows are the columns. That's what transpose is basically. So another way of doing it is by just saying array, calling your array 2D dot T. So this is a shortcut. Like this is a shortcut. So if you just say array 2D, your array then will transpose dot T. So it will do the same thing. It will transpose your array for you, right? So it's going to transpose your array for you. So yeah, that is it basically. So you can, as you can see, I also transpose the three-dimensional array, right? It basically carries the number of channel to become the number of columns, and it carries. Let me just quickly illustrate that. Time. All right. So this is our three-dimensional array, right? If I transpose it, this 3 would just come to the back here, right? It will come to the back here, and this 2 will come to the front. So it will now have, instead of this normal 3 channel that we have and 2 rows and 2 columns, we now have dot T. Oh. We now have 2 channels, 2 rows, and 3 columns. So just, yeah, that is basically what you're going to get. So quickly, we can also join and split our arrays, and there are functions for that. So joining your array is what we call concatenation. So most times you'll be concatenating your array in NumPy, right? So using the function np.concatenate. So let's just quickly illustrate that. Um, so we have, let's say we want to join our 2D joining or concat. Let's use it. Um, okay, I think something happened. Let me just quickly share my screen. All right, so can you all still see my screen now? All right, all right. Okay, so I was talking about concatenating our arrays, right? So we can actually concatenate, join our maybe two arrays together. So how do we do that? We can basically just use the concatenate function. So I illustrated here concatenate arrays using np.concatenate. So it takes in, okay, you have to put in the brackets because the two arrays are going to be seen as one. So you just come here and say array 3D. So now, if you do this straight away, it's going to give you an error because NumPy does not understand where you want it to join from because this is a two-dimensional and three-dimensional arrays. So you have to specify the axis to concatenate from or to join from or join with rather. So remember I said we have two axes in NumPy. We have axis 0 and axis 1. So please can you tell me what axis 0 is and what axis 1 is in the group chat? I remember I said that in the previous classes. I talked about the axis 0 and axis 1. Can you please just tell me what axis 0 is and axis 1 is? Exactly. So axis 0 is the row, while axis 1 is the column. So now once we are using the concatenate function, we have to specify the axis we want to concatenate from. So remember axis 0 is the row. So basically if we put axis here equal to 0, we're telling Python that it should join them um, by row. That means you add more rows to it. So let me quickly come here. That's reshape. Mm, okay. So there's a conflict of shapes there, so I don't want to dwell much on resolving that. So now we have two arrays that we want to join together, right? We want to join two arrays. So what we just did now is we joined array 2D that we created with itself. So you see the first part here, and then you see the second part here. So it basically added more rows by adding the other array to it. So that is what this axis 0 is, right? So and you have to actually pay attention to the dimension because if we say axis 1 here and we run it, right? So it's going to give us the same thing. Like it's going to add the new array to the columns. So the columns will be extended, right? So this is basically what we're going to get. So you also have to pay attention to the shape of the arrays you're adding. Because let's say you have something like this, reshape What exactly is the shape again? So 3 by 4. Say I have 6 by 2. Um, this is 1. It's going to give us an error. So what I basically just did here is I changed the shape of the second array that I want to like concatenate with this array. Okay, let me make this easier to understand. I have my new array here. Let me say new array, right? So I'll come here and say new array. So now, yeah. So we have two arrays, right? We have the array 2D. What shape does it have? It has 4 by 3. I'll be 3 by 4. Let me print out the shape. Array 2, right? And we also have the new array 2. New array. So if I print these two arrays, as you can see here, this is the array 2D is 3 by 4, and this is the new array. It is 6 by 2. So if you want to concatenate these two arrays, it will not work because that's what I tried to do here and it's giving me this error. Now, you remember what I said in initial time that most errors you'll be getting in NumPy will usually be due to shape mismatch, dimension mismatch. So you really need to understand how you are working with the shapes of your array. So if you want to concatenate these two arrays, remember that the axis, let's use axis 0 now, would carry the second array and put it on the first array and join it together. So, but this second array now, this one that we have here, has just two. It has for it to be able to perfectly align with this first array that is here, it needs to have 4 columns so we can place it under. But it has just 2 columns, so it won't work. It won't work, right? The same thing for the axis 1. If we are stacking it along the column axis, it won't also work because we have 6 rows here, and for the column axis, we're supposed to have we're supposed to have exactly 3 rows for it to perfectly align with this one so we can extend it. So the shape of the two arrays you want to concatenate has to be the same thing. It has to be the same thing. That's what I'm trying to say here. If not, it's going to give you this particular error that we are seeing here, right? So if you read your error, you would almost always understand what it's trying to tell you, right? So all the input array dimension except for the concatenation as must match exactly. Are you seeing it? All the dimensions must match that exactly. So you need to make sure that your array here is the same thing. So as you can see, we have 3 by 4 now. So your array is going to perfectly concatenate it with the array that you already have here. So what am I trying to bring up from here? Pay attention to the shapes of your array. Very, very important. Pay attention. Like if you don't understand the shapes of your array and how to use these shapes in different operations in NumPy and different manipulation, you are going to have a lot of problem. You are going to have errors and probably give you headache. So just be careful with that. So that's it for concatenation. And now the other ones we have here, they are basically the same way of doing this concatenation, but they are different functions. So vstack now this is an easier way to do it. So vstack basically is the same thing as let me just illustrate here. If I come here and I say using vstack, vstack aligns them vertically. That's what the V stands for. So vertically is from up to down, right? So it is like just saying axis here is equal to 0, right? So if I come here and use the vstack method, I will say vstack, and I'll just give it the arrays that I already have, array 2D, and just use array 2D again, array 2D. So I don't need to um, put in or specify any axis here because this function is automatically aligning it on the row. So if I run this, this is what I'm going to get. All right, so this is straightforward. It's more straightforward than the concatenate. So probably you might not even use concatenate much, like since you already have this V stack. So that's what one thing I like about Python. It gives you different ways to do the same thing. So this concatenate is probably the previous versions of NumPy. So as the newer versions of NumPy came, they started to like make it easier for people, and we had this V stack. So the H stack is the same thing. So if you come here, we have H stack, np.h stack. So it stacks your array horizontally, assuming your axis is equal to 1, right? So if I come here and say, okay, let's say using H stack, this one is horizontally, right? So you can say np.h stack with your array 2D. I'm just using the same array just for simplicity purpose because they have the same shape. So any array you are using here, they should have the same shape, right? So array 2D. So no need to specify the axis here like concatenate. So if I run this is what I'm going to get, right? So there are just the same way of doing the same, different ways of doing the same thing. So that is it for concatenating your array. So we've basically gone through the different things we can do in array manipulation. We've learned how to reshape array. We've learned how to flatten arrays. We've learned how to transpose arrays. So we've learned how to concatenate. So it remains splitting. Right. So this splitting can be a little bit complex, but let's just go through that. So once I think we have like about 10 minutes to go. All right. So now for splitting array is basically you want to split a bigger array, right? You want to split it into two different arrays. This is different from slicing. Slicing is taking a subsection of an array and bringing it out. While splitting is like dividing that array into two, right? Into two. So let me try. Let's just demonstrate it now. If I splitting an array using np.split. Right. So let's say I want to split this array now that we concatenated. Let's assign it to a variable here. Combined array. All right. So I want to split the combined array into two. So I'll come here and use the np.split array, and then what I'll have to put here, it takes in 3 arguments. The first argument here is the array you want to split. So I want to split the combined array. The second argument is the index, the positions you want to split. So I will explain that. So, but let's use 2 and 4, right? Let me have to print the array. So you see combined array, right? So and then the last argument, there's the axis. So you can also specify the axis you want to split it from. So you will see axis 1. All right, so let me comment this out and print the combine. So this is the array now that we want to split. So what this does is that we are splitting, first of all, this is the axis you are splitting along the column. So you want to split it column wise right? So basically, once you split it, it's going to have 2 separate arrays with the same number of rows but different number of columns because you are splitting the columns. So what this to mean here is that you will count from here, from first index, second 0, 1, 2. It will split this one. And then what 4 means is that it will split from that 2 to 4. Then 6, 3, that is 0, 1, 2, 3, 4. To split then this one, and then it will now produce or split the rest. So you basically have 3 splits here. So as you can see, we have 3. This is the first split. You can see 3 and 4, right? So this 2 here is like the index 2, and this 4 is the index 4 at the column axis. So you're counting the index column wise: 0, 1, 2, 3, 4, 5, 6, 7. So this 2 is like, okay, split from 0 to 2 first. So this is 0, 0, 1, 2. And remember, in Python does not always include the last index. So it will just split 3 and 4. As you can see, it has split 3 and 4, right? That's the first split. So this second number here means from this last place, from this last index, split until you get to 4. So the fourth index here is 0, 1, 2, 3, 4. So this is the fourth index, right? This 3 now is the fourth index. So it stopped at 4. It now split 5 and 6. So this is what you are getting here, 5 and 6, right? So once it does that, the remaining values would just be, it will just split automatically. So this is a list of splitted array. So if you want to get any of the array there, you can just, let's just assign this to a variable. I know this is already getting a little bit complex now, right? So but I believe, I want to believe everyone is still following. Splitted. Okay, let me just say split array. Right. So I've assigned it to a variable now. So I want to get, remember, the splitted array is a list of 3 different arrays you splitted. So if I want to get the first array, I can just index it, array.0. Right, let me remove this one. You see, I'll get this first array, right? If I say array.1, I'll get the second array. So array.2, I'll get it. So I basically splitted that combined array into 3 different arrays. Like, is that clear? Is that clear? Okay. So that is it for splitting arrays. So we've gone over concatenation and splitting. So these are things that you'll be using in working with your arrays, right? So because of time, we're going to have to stop here for today. So we'll take questions. Tomorrow is another day. Hopefully by God's grace, we'll be starting with pandas tomorrow. But before we do that, we'll just wrap up with NumPy. We still have some other concepts to discuss in NumPy. So we have aggregation functions and statistical operation, right? So we can use a lot of, or we can do a lot of other things with NumPy, like statistical wise. And we can also we'll also talk about what we call random number generation. So we'll just talk about this before tomorrow's main topic, which is pandas. So we'll be introducing pandas tomorrow. So just get ready, go through the book that I've posted. That is going to be a good guide. Like, it has everything you need for this particular program. So don't just always wait for the lecture. Try to read higher, try to read materials, read wide and far. Right? So because there are other examples that would help you understand this better, but because of the time constraint, you might not be able to practice or to use all those examples, right? So yeah, that is it for today. We come to the end of today's class, and I'll be taking questions. So if you have questions, please can you indicate by raising your hand? All right, Moses, you can go on. I've unmuted you. Yeah, Moses, you can ask your question.
Good afternoon, sir.
Yeah, good afternoon.
I really want to say a very big thank you to you for the simplicity of this program. Yeah. My first question is concerning this program. Can someone still be able to register to join the cohort 2? That's one. Then number 2 question is, You were talking each time you mention Python, you mention NumPy. I'm beginning to get confused. Whether is Python different from NumPy or NumPy is a subset of Python? Then the third question is about the reshaping. We talked about we said, how does this reshaping works? Because I really do not understand when you were making mention of it. When we were doing multiplying by 7, that time we multiply by 7, just one column multiply a number and we broadcast it into the normal part. Now, when we now do into 2 column, each of the two is supposed to multiply that thing finish and then come back to 3 again, multiply it. I'm expecting that it should broadcast the 2, broadcast the 3, broadcast the 4, and broadcast the 5. But here it just says only one time it will do it. That time we are treating broadcasting. So I really do not understand. I'm bringing my knowledge from mathematics when we are doing matrices. So I really don't
Yeah,
get the broadcasting side. That time we multiply by 7. Please, you can
yeah, yeah.
check for me.
Yeah, thank you for the question. So your first question is can someone still register for the program?
Yes.
You've actually gone far. Do you mean this particular cohort we are in?
No, no, this cohort, that's for subsequent one now. I told somebody that I'm in a program like this, so you thrive. And the person was like,
Okay.
he wants to register, he wants to join. I said, we have already started. He said, what is there no other? I said, I said, we think we have another cohort, but I really do not know when it will happen. So
Okay.
is there a way somebody can join us? Maybe not this particular one.
I'm actually not in the right position to answer that question. You'd have to redirect it to the community manager or the facilitator. That is the people
How do
there.
I get to them?
What do you say?
How do I
They'll,
get to
they'll,
them?
um, I'll tag I'll tag them on the group chat, or you can
All right,
DM me
thank you.
and I'll just give you the contact. All right. So for your second
Okay.
question on NumPy and
And the
Python.
Python, what are they the same or different?
Yeah. So Python is a programming language, right? So it's the overall platform, right, that we are using NumPy in. So if you follow, you would know that NumPy is a library in Python, right? So
Okay.
NumPy is a library that is built for a specific purpose. So whenever we are talking about everything that is related to NumPy, I'm going to be able to be using NumPy, right? So you know that this thing is specific to NumPy. So I'm just trying to make that separation so you understand exactly what I'm saying. So that's why sometimes I say Python, sometimes I say NumPy. So when I'm referring to general use cases, I will say Python. When I'm referring to specific cases or examples, I would make reference to NumPy. So just understand
Okay.
that they are not
Okay.
conflicting in any way. So for your last question, about reshaping, I, I
Yes, I asked,
actually
how does it work?
I actually don't know if I got your question, understood the question, but I can you just rephrase so I will not waste my
I
time
said,
explaining.
how does the shaping work? In the sense that maybe you have a two-dimensional array and you now put in the function to reshape. How does
Exactly.
it arrange the numbers? It's just know yeah, it's how does it know how to put with the one where it's supposed to put? Whether is there a code or a program for it that we are not seeing that makes it to be able to arrange this number?
Okay. I think I get your question. How does like the orientation of the whole thing? Is there any pattern to it, right?
Yes,
Um,
sir.
for example, now you have um array 2D, right? And you already have
Okay.
your array 2D that is 3 by 4. So if you reshape to, let's say, 6 by, let's come here, array 2D dot reshape to 6 by 2. Right, but before I do this, let me just print out the initial array. Um, mm, Okay. So now this array now and this array, they are the same thing, right? So this is 3 by 4 and this is 6 by 2. So the thing is that there is actually um, no specific, like it's not something that you will understand, right? It's something that NumPy does behind in the back end. So
Okay.
there is no pattern that it follows in terms of reshaping. So if we try to just let's just assume we want to try to understand the orientation of each element. So we come here and we see that we have 3 3 5 as a row here, and in the row here we have 3 5 3 3 5 3, right? And
Yeah.
we have 3 4 4 2 3, right? So there is no pattern. You can actually not decipher any pattern that represent or that is used in reshaping this array. So it just does it. I don't know if I should use the word randomly, right? But it reshapes it.
Okay.
It gives
Okay, sir.
exact shape you want. So whenever you are reshaping, the orientation, there's something I want to point out so you understand. This thing this question you asked, it is not important to know how it is reshaped. It is the shape that you're actually concerned about. Right? If you are reshaping something, when you're working with a data and you're reshaping it, the reason why you're reshaping it is because you need this particular data to be in this particular shape. So you already
Okay.
have the target shape in mind. So you don't care how the orientation or the position of each number would is not going to be your issue. Just trust me on that. Like, it is not
Okay.
going to be your issue. Right? Your issue is
Thank
just get the actual shape that you want for that particular task that you are doing. So
thank you,
I
sir.
don't know if that is clear enough.
Thank you very
So
much.
if you have any, someone raised your hand initially. Um, Francisca, I think you raised your hand. Are you still asking question? Let me unmute you. Yeah, Francisca, you can go on to speak if you still have a question. And I think someone else raised their hand. So please, if you have any question, just indicate before we call it a day. All right, Mohammed. Yeah, Mohammed, please go on. Mohammed, you raised your hand. You're on mute now. You can go on to speak. All right, Kim David, you are muted.
Yes, sir. Good evening.
Yeah, good evening.
Yeah, thank you, sir. My
Yeah.
question is about broadcasting that you explained. Apply
All right.
two arrays. Not multiply two arrays.
Hello?
Hello, can you hear me, sir?
Your line was breaking.
But can you hear me now?
Yeah, I can hear you.
All right. I said my question is about the broadcasting that you explained. If we want to
All right.
multiply two arrays, say I have array 1 and array 2, and the array 1 is stated. For instance, it is a 2 by 2 array, and the second one is a 2 by 3 array. Of course, it does not meet the
Yeah.
requirements for multiplying the two. So my question is, which one is adjusted? Which one does NumPy adjust to meet the requirements? Does it always go for the second one, or it can also go for the first one just to meet the condition for doing such kind of multiplication?
All right, good. So let's just quickly. You said the first array is what? 2 by.
Let's say it's a 2 by 2 array,
Okay. 2 by 2 array.
and the second one is a 2 by 3 array.
So you have these two arrays now, and you want to
Multiply them.
multiply them, right?
Yes,
So
sir.
if you just go straight ahead to so this is what you're going to get, right? Operands will
Okay.
not be broadcast with shapes 2 and 2 and 2 and 3. Um,
Exactly.
there's actually yeah, I made mention that for you to multiply two arrays, but I was using just one dimensional array there when you have one dimensional array. But in cases like this where you have the same dimensions, like let's assume two-dimensional arrays, so obviously your array is the same thing. Like this is something I talked about initially when I was doing the
Yes, sir.
element wise operation, right?
Multiplication.
They have the same thing, right? So
Yes,
is
sir.
in cases where you have an array that is a dimension and another array that is in a lower dimension, that NumPy will now have to broadcast that lower dimensional array to meet the larger dimensional array so that
Yes,
it
sir.
would multiply perfectly. So if you have an array where the two dimensions are the same thing, then you're just going to follow the normal element-wise operation that we talked about. Like each of the elements in the two matrices or array has to be they have to be the same thing in terms of the shape. So this one you just mentioned now is not
It's not possible.
is not a condition for broadcasting. So a condition
Oh,
for broadcasting would be when the second array is just a one-dimensional array. Like we have your
okay.
first array is 2 by 2, and this your second array is this 8 by 4, right? So if you multiply the two now, it's going to broadcast it, right? Remember that this one now is just one dimension, this one is 2 dimension, right? So it will be
Okay.
broadcasted this way. We are going to have 3 and 4 broadcasted to meet up with the array of this upper one. So your question basically was that which one will be adjusted to which particular array will be adjusted, right? So it
Yes,
is the
sir.
lower dimensional array that will be adjusted for the higher dimensional array. You
Okay.
get
Okay. Yes, sir.
so it is always in a case where the two arrays you are trying to perform an operation on are not in the same dimension. So if they're in the same dimension, there is no need for broadcasting. The two arrays should have to be the same shape, right?
Yes, sir.
All right.
Yes. Then the
So
second part of my question, sir.
yeah, I
Hello,
can
sir. Are
hear
you
you.
there? Yes.
Yeah.
You also give us an example where you multiplied with an integer. Does it
Yeah.
does it matter where you place the integer in your code? In the example you gave us, the integer came after the array was given. So does it matter where the
No, it doesn't
integer is
matter.
located? Okay, okay.
It doesn't matter.
All right.
It
Thank you,
doesn't
sir.
the positioning it doesn't matter.
All right. Thank you,
All
sir.
right, Omalade, you can ask your question. You're on mute, Omalade.
Okay, can you hear me now?
Yeah, I can hear you.
Okay, my question is good evening, Mr. Ima. My question
Yeah,
is I don't really understand the line space, although we didn't talk about it this week. But I saw it when you were, trying to correct the assignment. The line space and the slicing of arrays.
all
That's
right.
my
Are you a new
question.
student?
Yes, I'm a new student.
Okay. Um, yeah, it's understandable. Have you gone through the second video, the video on NumPy that we did last week?
Yes, I went through it. I
All
was
right.
in class last week now.
Okay. Were you? I believe I explained it then. I don't know, but let me just go over.
Okay.
Mute your mic.
All
So
right.
basically, what list space does is that it creates arrays within a range. Let's say if I have 1 and 4, this is like your A range. It creates arrays between this range, but you also have to include the last argument, which will tell you how many arrays it will be creating between 1 and 4. So if I put 3 here, I'm going to get 1, 2, 3, 1, 2, 3, 3 elements, right? Because that is what I specified. The last argument here means the number of elements that they are that will be in the array. By this one mean this is where to start from, and this 4 mean this is where to end, right? So that's basically what list space. You create arrays within a confine, and you also specify the number of arrays you want to create within that confine. So if you have, like, let's say 1 and 40, 1 and 40 here, I want to create 50 values between 1 and 40. You can use linspace. So it is going to create 50 values between 1 and 40. So you would have something like this. So 1 is the starting point, and then 14 is the ending point. So all these ones are it generates them. Like, you don't need to bother yourself how it generates the value. But these values, they are evenly spaced values, that they are the same, they are uniform, right? So everything is uniform. So all those ones is not really of concern. So that's it for linspace. What was the second question again?
Yeah, my second question is slicing an array.
All right, so slicing an array, I would actually advise you to still go and rewatch the video on the linspace and slicing of array, so you understand it better, right? Please, can you mute your
Okay.
mic?
All right.
But let's just quickly go over that. So for slicing array, let's assume you have your array 2 that we created, or let's say array 2D. So slicing basically means taking a part or a portion of that array, right? We're already overshooting. But now, and you have to, for you to slice, you have to understand the dimension. So in this array, what exactly is the dimension of this array, the shape of this array? Do you know the shape of this array? This is a 3 by 4 array, right? So now let's assume you want to get this particular element, this 4. You need to know the position of this 4. So this 4 is in the first row, second column. So that is the row index 0 and the column index 1. So you have to specify it in the slicing syntax. So you have to put 1. 1 is usually 0. The first value is usually the row, while the second value is usually the colon. So the colon here is what? 1. So if you run that, you're going to get 4. So you have to understand the position of the elements you want to slice. So that is it for that. So you can just go over the examples that we gave in the previous videos to help you understand more. So because of time, we won't be able to give more examples. So please, if there's I'll be taking one more question and then wrapping up. Is there anybody with question? Hope I was able to answer your question, Omalaje.
Yes. Thank you.
All right. All right, welcome. So please just try to go over the Python PDF I sent to help you explain better, and also the videos too, the previous class videos. So I actually took my time to explain it there. So is there another question? Any other question before we call it a day? All right. So in the absence of no other question, would be wrapping up for today, and I'm looking forward to tomorrow's class. So tomorrow's class would be a continuation of today's class and also an introduction to Python, right? So I hope to see everyone tomorrow by 5. Tomorrow's class is from 5 to 7, so I hope to see you there. Thank you for joining us today, and have a beautiful day. I have So enjoy the rest of your day, everyone. Thank you for joining, and enjoy the rest of your day. Thank you very much. You can exit the video call now. All right.